So our topic is measure of dispersion. So from the previous class, we had covered measure of central tendency, whereby we had the mathematical average, and then we talked about the mean. Then we had positional average, we talked about the median and the mode. So our question or our NB is, given a data set, we can find the mean, mode, and the median, and this entirely tells us about the distribution of the data. However, is that what only you can do? You can do with data. So that's like a form of a question. We need to ask ourselves, is that the only thing we can do with data? So when we talk about the measure of distribution, is we try to understand how data deviates away from the measure of central tendency. So our main key, we understand how data deviates away from the mean, it deviates away from the mode, it deviates away from the median. So when we talk about the measure of central tendency, we talk about things such as range, we talk about things such as coefficient of interquartile range, we talk about semi-quartile range, we talk about things such as variance and the standard deviation, we talk about things, number 5, we talk about mean deviation, and then number 6, finally, we talk about coefficient of variation. So let us speak about range. From our high school, we were told that we have the upper quartile and we were told about the lower quartile, and we have what we refer to the 50th quartile, whereby this is the median. So when we are given any data set and we are asked to find, this is Q3 in most books and this is Q1 in most books and this is given as a Q2. So when we are asked to find the range, in that case it is given by the upper quartile, we subtract the lower quartile. and in that case it is given as Q3 minus Q1. So this one gives us the range. So how do we go about finding Q3? Q3 is given by L1 plus 3 over 4 n minus CF. We have H over F, whereby L1 is the lower limit, it's the lower limit of the Q3 class. N is the number of observations, and the other time we say it is the summation of F. Then we have CF is the cumulative frequency of the preceding class. That's the class above the Q3 class. Then we have H is the class width. Then we have F is the frequency of the Q3 class. How do we go about Q1? Q1, we go about it L1. We had 1 over 4 n minus CF. We multiply H, then we divide by F. So the denotations L1, N, CF, H, and F, they remain the same. So let us assume, and then somebody can ask about the Q2, the median. Let me make you remember, we used to do N over 2 minus CF H over F, and this one doesn't divide L1. So assume we are given data, we are talking about the class, then we talk about the frequency. I'm not going to do it complete because I think you can do it by now. So we have the class 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Then we have our F to be 5, 15, 25, 35, and 45. So given that kind of data, you can add it, you can submit F to find what we refer to as N. So we have 5, 15, 25. We have already, this is 40, 45, 50, 80, 125. So our N is 125. So because we see the CF, you come up with a CF there. You will be having 5, you'll be having 20, 45, 80, 125. So when you are looking for Q3, you will be having 3 over 4 times 125, whereby you are going to find it to be something, when we divide this, is going to be 3 cal 1, that's going to be 3. We have that point, that is 30 point, maybe 1. So when you multiply, that is like 90.3. So you check with the CF, 90.3 is going to lie around this. So this is going to be our Q3 class. So having in mind these are Q3, then we can pick L1 to be 40 because the classes are continuous. Then we have 3 over 4 multiply N is going to be 90.3. Then we have CF, we are talking about the class just above, it's going to be 80. Then we are talking about again F. F is the frequency is 45. So you can substitute that and do with it. So you can, when you feed that into the Q3, it's going to be given by we have 40, we are going to add 90 minus 1.1, 90.3, then we are minusing 80, then the cross edge is going to be 50 minus 40, which is 10. So we have a 10, then we are dividing by 45. So you can come up with Q3. So you can go work for Q1, you can go work for Q2. Then that's how we go about the range. Then we have the coefficient of interquartile. The coefficient of interquartile range, it is given by Q3 minus Q1 over Q3 plus Q1. So I think this one, after using the data we had, if you manage to come up with Q3 and the Q1, you can just substitute, then you get the coefficient of interquartile range. Then we talk about same quartile range. This one is given as, it is like range divided by 2, where it's going to be Q3 minus Q1 over 2. After that, we have something we call mean deviation. We have what we refer to as mean deviation. This is where you are told assume the mean is maybe 10. Then you are given data set. Let us assume you have 0 to 10, 10 to 20, and 20 to 30. Then you are told this is maybe marks. Maybe it was a cut marks. Then the frequency may be 5, 10, and maybe 6. So when we talk about the mean, you remember we have to find the midpoint. So the midpoint is going to be 5, 15, and 25. Then you are told to assume the mean. So you take the midpoint. When you are told to assume, you subtract that 10. So 5 minus 10 is going to be negative 5. 15 minus 10 is going to be 5. 25 minus 10 is going to be 15. So you will come up again. You find summation of midpoint minus 10. In this case, you are having f minus those, so you are going to have 5 times negative 5, which is negative 25. You have 5 times 10, which is 50. Then you have 15 times 6, which is 90. So when you add this is 25 plus this is 115. So when you are going to find the mean, you remember the mean, the arithmetic mean is given by summation of fx minus divided by summation of f. But in this case, it's going to be summation of f minus this x here minus a over summation of f. So because we had to subtract a, you take the mean is going to be a plus summation of f into xi. Let us call the midpoint xi minus a over summation of f. Don't cross divide that way, you have to use the method. So it is going to be 10, you are adding, ours is going to be 115, divide by, we have 5, 10, and 16. So this is going to be 21. Hope you can find the answer. That's how we go about the mean deviations. Okay, we talk about another thing. We talk about variance and standard deviation. Variance and standard deviation. Variance and standard deviation. So let us use the same data we had. Let us assume Number one, the variance is given as summation of fx minus x bar. This is squared, then we divide by summation of f. That's how we go about the variance. So this is in case where we are talking about grouped data. We have also ungrouped data. The variance is given as 1 over n summation of x minus x squared. So in such cases, let us use group data because it is so common. We assume maybe marks and frequency. Let's assume 0 to 10, 10 to 20, 20 to 30, and 30 to 40. Then we want to assume a frequency of maybe 4, 5, and 10. So the moment you are told about the variance, you have to look for what we call the mean. So you have to find the midpoint first. So then this is going to be 5, 15, 25, and 35. Then you are going to find fx, calling the midpoint x. So we are going to have 20, 75, 250, and 35. Adding those, this is 270, 270 plus 110, 380. So we find the mean to be summation of fx over summation of f, which is 380 over 20, which is going to be 19. So our mean is 19. X bar is 19. So the x bar we are talking about here, x bar is the mean. So that is so important. So we had another column because we are looking. Our main agenda is going to find the variance. And the variance we are talking about summation of f into x minus x bar squared over summation of f. So we're going to find another column, x minus x bar. Our x bar is 19. So we have x5 minus 19, which is negative 14. 15 minus 19, which is negative 4. 25 minus 19, which is 6. 35, this is 16. Then now we had another column, x minus x bar squared. So 14 times 14, which is 196. The negative disappeared because we are squaring. Then we have 16, we have 36, and then we have 256. Then we have f into x minus x bar squared. So your f is 4, you are timesing 196. So we have 196 times 4. 196 times 4, that is 4, we carry 2, that is 36, 38, we carry 3, that is 784. 784. We have 16 times 5, which is 80. We have 10 times 36, which is 360. Then we have 1 times 256. So now this is what we summate. Gets f x minus x bar. So we have 784 plus 256 plus this is 440. It is going to be 0, cal 1. 8 plus 4, that is 12. 12 plus 6, that is 18, cal 1. Then we have 9, 10, 14, 20. So it becomes 14, 20. So because we are finding the variance, and in most books you are going to be finding the variance is indicated as sigma squared. This is sigma. So the variance is going to be given by summation of f into x minus x bar squared over summation of f, which is going to be from the what we have, it's 1420 divided by our frequency is 20, so we are going to have it to be 71. So our variance is 71. Our variance is 71. So when we talk about now standard deviation is sigma, which is the square root of variance. So from the data we had, our variance was 71, so the square root of 71, something like 8, this 8.7 and some dots. So the standard deviation is the square root of variance. Then finally we talk about coefficient of variation, and in most cases it is a percentage. And it is given by the standard deviation divided by the mean, we multiply by 100%. So in most books you are going to find it is given as sigma, not sigma squared, over x bar times 100%. So whereby sigma, this is standard deviation, and then x bar is the mean. So I want during your free time, read about quartiles, do more practice about variance and the standard deviation, and look at what we refer to as percentiles. They will be so important in the next class. Thank you.